As compared to the relevant cost we used in spatial decision making, there are also a few common types of irrelevant cost that we can ignore in the decision-making process. The most common irrelevant cost is sunk cost, which is related to the acquisition cost of the old equipment or other assets. For example, when you're trying to make a replacement decision for all the equipment, the book value of the equipment, which means the remaining value of the equipment, is irrelevant in the decision. So normally that means whether you are trying to replace the old equipment with a new one, the remaining book value of the assets is irrelevant because it's already happened in the past. It doesn't matter you replace the equipment or not. Those costs wouldn't be saved or recouped by future decisions. Also, unavoidable cost, which normally referring to the common allocated overhead cost when you're trying to make a special order decisions or try to job or keep a product line will be irrelevant in the decision-making process because this common allocated overhead is the fixed cost. So it's related to the relevant range of the production. As long as you keep the production, it doesn't matter the volume of the production or the number of the products under the process. This common allocated overhead will continue to incur if you don't accept the special order or if you keep the products. So they are also irrelevant in the decision making. Finally, the non-differential cost items between the different options. For example, if you choose to live and work in Austin and Houston, the food cost will not be much different. So you may say the housing cost matters, the commute cost matters, and the entertainment cost. But the food cost pretty much will similar between the different cities. In that case, when you compare the two options, we can drop the food cost as the differential item in the decision making. Okay, so those are three types of common irrelevant cost. Now let's take a look for an example of equipment replacement so we can identify more clearly how to identify the relevant items and irrelevant items. And in this case, we have a old equipment can be used for another year, so 1 more years of life, the old loader. And we have the option to replace the old loader with a new one, also has 1 year of life. This is a simplified situation because we are assuming the useful life for both equipments, new and old, are both 1 year. If the remaining years for operation is longer than 1 year, like 2 years or 3 years, that will add some complexity into the analysis because the cash flow, like the operating cost after 1 year, we need to use the time value money concept to discount the future operating cash into the current present value. But if you only have 1 year for the useful life, it's still a short-term decision. So we can ignore all of the time value of the money concept. So we just let you know when the time horizon change, the way we analyze the situation will be kind of different. But now let's come back to this 1 year situation. So if you continue use the old loader, you have the information or the data for the original cost, and then the remaining book value of the older loader is 25,000. So that means we already depreciated the equipment for 75,000. And then if we dispose the loader, we have a remaining value we can still receive. For example, you may just sell it for cash, 5,000 value. But the operating cost, so annual variable expenses related to operating the equipment, such as the maybe like the labor involved and other operational expenses is high, so it's 80,000 per year. As a comparison, the new loader we are looking for, you need to purchase, so the purchase cost is 15,000. But the operational expense annually is much lower than the current, so the older equipment. So this one, the annual operating expense is only 45,000. So clearly we can see if you replace the old equipment, we can have an annual operational expense saving between 45,000 and 80,000. But we need to pay extra cost for purchasing the new loader. So what will be the decision, okay, the result, the outcome? So let's try to analyze it using the 7 steps of decision-making process we recommended in the beginning. So first, you identify the decision problem. So our problem will be replace of the old loader using a new loader. Okay, so question mark. So replacement decision. And then the criteria should be the total operating expense or like the cash flow minimized, because here we haven't touched on the revenue. We couldn't really compare the revenue, but also the situation you're assuming you are making the same number of products and we are selling the same number of products. So probably the revenue will be no different between the two options, right? So no differential items, so non-differential items is irrelevant. So we focus on comparing the total operating expense or the cash flow, so minimize the cash flow or the operating expense. That's your decision criteria. And then we have two options, right? Two options: keep the old loader or purchase the new one to replace the old loader. And then collecting data, we already have the related data here. And your decision model will be try to compare the operating cost. So which one is lower, right? So that's kind of related to the decision criteria. So now we need to plug in data into the modeling, or we compare the operational expense between the two options. But before you do the numerical comparison, we need to understand and identify, do we need all of the data or information we pulled from the system? So do we need all of the numbers presented here in your decision model? So let's identify, check each of them one by one. For the new loader, the purchase price is definitely relevant because this is a differential item. If you keep the old one, you don't need to spend this 15,000. So 15,000 is relevant, a new cost. The annual operating expense for the new loader, 45,000, is also relevant because this one is the benefits if we use the new equipment. We have a lower operating cost than the older one. So differential from the current situation. So compare the 45,000 and 80,000. So these two items are also relevant. And then looking for the old equipment. the disposal value, which is a opportunity cost. If you keep the older loader, we wouldn't be able to dispose it, so you wouldn't get this 5,000 benefits. This is the opportunity cost if you keep the old equipment is also relevant. Then finally, the original cost and the remaining book value of the older loader, 25,000 or 100,000. Both of them are sunk cost. 25,000 is the remaining value of the 100,000 because it's incurred in the past. If you keep the older loader, it will be depreciated over the 1 year. Or if you replace with the new loader, we'll recognize a one-time loss of the 25,000. So non-differential between the two options. Both you will lose the 25,000 by depreciation or by a one-time loss. So the critical factor in comparing the options is we should ignore this 25,000. If you think, oh, I will lose this 25,000 if we replace, and we can save this 25,000 without replacing, this approach is wrong. Okay, you will get a inaccurate result. So they have some more explanations in the next two slides. They explained why this 25,000 is not relevant as a sunk cost. And then, so if you replace it, or like, you can see the depreciation, okay, the cost. We'll only have depreciation on the new loader if we replace the old loader, which means the purchasing cost, the 15,000. Because the new loader only can be used for 1 year, this total 15,000 will be depreciated over the 1 year period. And also the 5,000 proceeds by disposing the older loader is an opportunity cost, or is an opportunity cost to use the older loader, which is relevant. And thirdly, the operating cost, or the difference between the operating cost is relevant as well. So you can use a full analysis. So this approach they call total cost analysis. So total cost analysis, you present the total cost for each of the options. Keeping the older loader, you will have the 25,000 book value depreciated. Then plus the annual operating cost, you end up with 105,000. But if we decide to replace the older loader with the new one, you will have a one-time loss. So write off the older loader, so 25,000. But we'll get a benefit to opportunity cost 5,000 for the disposal value of the older loader. But we need to spend 15,000 one-time payment will be depreciated for the 1 year, and plus a 45,000 annual operating expense. But end up with 80,000, still 25,000 lower than the current situation. Okay, if we pull all of the information into the comparison. So finally, the differential cost. Remember, our criteria is choose the one to minimize the total operating cost. So replacing the older loader with the new one will save you operating cost for 25,000. So if you just choose by the financial result, you should choose the new equipment or replacement option. So this approach we call total cost analysis. And after practice, if you get more confident with the information like the data, clearly you can see you can ignore the 25,000 in both of the decisions, right? Because they are the non-differential cost. You can focus on the items are different between the different options. And this will end up, we call, I think, do I have the, yeah, this one. So you can end up with a simple approach we call differential approach. So rather than compare with the total cost between the two options, I will focus on the difference between the two options. So I have a cost saving by using the new loader. Okay, so when you do the differential approach, you want to compare one option with the other one. So to be clear, what's the option I'm choosing, and then we do the comparison. So I'm assuming I'm replacing the old one with the new. So in that case, I will save an annual operating cost by 35,000. So that's the difference between 45,000 and 80,000. Then I need to spend 15,000 to buy the new loader. And then get an opportunity benefit by disposal of the old equipment. So adding all of the three factors, and then you got the same final result. So by replacing the old loader with the new one, so my idea is we can have a cost saving overall 25,000. Okay, same result as you use the total cost approach, but you can see it's much simple. But when you use the differential approach, you need to be very clear and confident on identifying and use the right items only. You will get the same result. So we call differential approach. So by using this equipment replace option, we practiced how to apply the decision-making process. But as I mentioned, there are some other factors that may change the result if you revise the assumptions. For example, if the decision period, like the useful life for the equipment, is beyond 1 year, we need to convert the future operating cost into present cash flow. Or that will be making the results looking kind of different. Also, if the new loader is more efficient, for example, it's like a more automated or AI driven, you have the potential to increase your production volume compared to the current one. So assume if you can make more units and increase your sales volume, it can bring more contribution margin into the production. Okay, so not only we minimize or reduce the cost, we also can increase the contribution margin or like revenue, okay, for the products. So that's bring more benefits if you use the new loader, right? So all of the situation, like the decisions, you need to analyze case by case, but focus on the fundamental ideas, but you need to think different, like variations of the situation so you can make accurate decisions. Okay, so those are the kind of like introduction is partially reviewing why the relevant cost is critical. So how to identify and use the relevant cost concept in special decision makings. And then the rest of the chapter will go over more examples of special decision makings, like, to implement the concept and the decision-making process. So we will practice more using different examples.